Hi guys, my name is Faizan and welcome to this session by Great Learning. So before we start, can you guys quickly give me a confirmation in the chat section if I'm audible or not? Is there any noise that you are hearing so that we can rectify it right here right now? And while we wait for others to join, Great Learning has come up with an initiative. We all know about it, right? Great Learning Academy, wherein we have 100 plus courses available for free for a limited amount of time. So you guys can check those courses and register yourself. After the completion of your course, you will also get a certification which you can easily add into your resumes and into your LinkedIn profiles. You are audible, no issues. Great. So yeah, what was I saying, that yeah, you can add those things in your resumes and all, and also you can add the projects that you did, the assignments that were given by the instructor, right? Those you can add in your resumes like a mini project or something like that, right? So now let's get started. So today's session is all about problem solving in programming. So we will see a step by step procedure how to approach a problem, and then how to come up with a solution. We'll also talk about something that is called time complexity, how to reduce time complexity as you solve problems, right? So today's right now we are in such a era in such an era that if you solve a problem, it's okay, but you have to solve it efficiently. Only then it is uh, worth doing it, right? Else everyone can solve a problem, right? It's not about that. It's about solving a problem efficiently, right? Now without wasting any time, let's get started, right guys? Cool. So let's see the table of content. What are the things that we are going to cover in this session? First, we are going to talk about problem. In what is a problem, how to introduce your problem. Not like that you are introducing to a problem, you think like you are introducing it to someone else. What are the things that you are going to tell him regarding the problems, right? So that we will focus on first. Then the flowchart, then the pseudocode, then the algorithm. Now you guys might be thinking, so why do we need this if we are solving problems? So these three parts for now, if you have just started your programming, and you are just starting your programming, or you are just started learning programming language and you don't know where to start, this is for those guys. And for those who have started and who are somewhat experienced, I want them to start solving 10 to 15 problems based on these, and then after that straight away follow these two steps, okay? For now, if you have just started your career in programming, you follow all these 5 steps, okay? So now let's see first what is a problem introduction. How do you go through it? Okay, great. So now, majority of the problems that you will face will be solvable by computers, although there are some NP hard and NP complete, NP problems, right? So those we are not focusing right now, but yeah, most of the problems are solvable, right? Now, few things we have to consider. What are the few things? First, analysis. What do you mean by this thing? We'll cover in the future, in the coming slides, right? Then the number of inputs and types of inputs, then output and its types. What is the type of the output that you're going to get, right? What you're going to send to the end user, right? Wherein your evaluation will be done, is this problem correct or not, right? Then you have constraints. What are the constraints? Then the flowchart, then the pseudocode, then the algorithm, and finally we'll do the implementation part. That will be separate thing, okay? That we will do, and I will show you how to go through one by one, how I will be reducing time complexity with simple methods, okay? Now let's see the analysis part first. So problem statement, it will be given to you a problem statement, right now I have picked this modified Armstrong number, right? So now this is the problem that it would have been given to you, right? If you think about this problem, let's suppose you are going in some websites, right? Or you're going in your question, let's suppose you are giving some exam, right? So wherein they won't give you directly, please solve modified Armstrong number. They will just add some 3 4 lines of English sentences, and they try to confuse you, but the gist will remain the same, that you are going to go, the problem is still that Armstrong number, right? You feel me guys, right? So quickly give me a confirmation in the chat section, you are following along quickly. Yes, no, maybe. Is everything clear until this point? How, why we are doing this thing, and how it helps us to solve a problem will be covered. Hey guys, can you just confirm now. Is it okay? Quickly, guys. We have lost a bit time. Sorry for that. So quickly, guys. Yes, no, maybe. Now is the voice clear? Has the buffering stopped or not? Quickly. Yeah, now it's okay. I can hear you. Okay, yes, it's fine. Great, great. So now, without wasting any further time, let's get started. Okay, guys. So now, where were we? So now it says that if it's equal to the sum of digits raised to the power to the total number of digits in the number, and it does not end with 0, right? So let's suppose this is a number. 153 is a number. Now it's saying that if it's equal to the sum of digits, how many digits are there? That means there are 3 digits, right? 1, 5 and 3. So to the, and each digit is raised to the power to the number of digits. That means 1 raised power 3 plus 5 raised power 3 plus 3 raised power 3. This comes up to be 1, and this is 125, and this is 27. So when you add these up, it comes to be 1. It comes out to be 153. So this is an Armstrong number, right? So, and it doesn't end with 0, right? This is a constraint that he is giving us, that this number should not end with 0, right? So now our task is to check if the number is Armstrong or not. So it is a boolean that we have to return either true or false. Okay, so that's the problem statement, right? Is it clear, guys? Quickly, yes, no, and is there any lag that you are facing, or is there any noise, echo, anything that is disturbing? Quickly, guys. Yes, no, maybe. Samim says yes, yes, great, great. So now this is the problem statement. Now comes the first part, that is our analysis part, right? So a number is given to us. Now let's look at these things one by one, right? Then a split second is buffer, but now it's fixed, no lagging, sir. Sir, can you repeat, please? So Rohan says, can you repeat? So Rohan, we just have started our problem statement. That means that we are trying to solve a problem, which is a modified Armstrong number, wherein we have been given a number, and this number is such a number that if every digit, if every digit of this number is raised to the power to the total number of digits of that number. Let's suppose this is 153, and therein we have 3 numbers, 3 digits, right? So 1 raised power 3, 5 raised power 3 and 3 raised power 3. If this number, if these digits sum up to the number itself, then this is an Armstrong number, right? The modified Armstrong number. And therein we have constraint. That means constraint means that constraint means conditions. In simple words, conditions. There has been one condition given to us, that means this number should not end with 0. So these are the conditions, okay? Conditions applied, okay? That thing. That means constraints, okay? So we have to just check if the number is Armstrong or not. Either we have to return the value or boolean value that is true or false. So now this is a problem statement. Now analysis, right? A number is given to you, right? The 153 was given to us, right? Need to check if the number is Armstrong, right? Correct. Now questions that can be asked, okay? What else are the questions that can be asked? Right now we are just returning true or false, right? There can be scenarios wherein you can be asked by the interviewer or your examiner, right? Ask the range. He asks for the range of numbers, right? He will give you, let's suppose, 10 to n, and n can vary from, let's suppose, n is 100. So he will ask you, give me all the modified Armstrong numbers from range 1 to 100, right? This can be asked. Ask for the input type expected, right? He will ask you to return me an array which contains all those elements, the output of the, how you can format this output, right? And total number of digits is given or not, right? So if there can be such a, again there can be a scenario, right? If 153 is given to you, there will be some scenarios wherein you have been given, okay, there are 3 digits, now calculate the Armstrong number. Okay, there will be some cases wherein you don't have, you will not be given these number of digits, you have to calculate these number of digits one by one, right? So these can be the questions that can be asked, right? So this is the analysis that you have to do, so that, right, it is impossible for you if you don't know the concept. Let's suppose there is some concepts and it's unique, right? If you haven't solved any question based on that, then it gets a little bit tricky, and you might be able to solve it in an inefficient way, right? In an inefficient way, but that won't be I mean to say, you won't be able to get through if you haven't seen that question. So you have to solve questions, and you have to look how many questions can be solved from that question. Okay, this is the intuition that you have to bring in yourself, right? How many questions can be asked, right? Therein we have just a simple question wherein I was just returning true or false. So these many questions can be asked based on the same concept, right? You have to think, you have to open up your mind and solve questions, and solve in such a manner that if any question that comes that revolves around this question, you will be able to solve it. Okay, great. So now this is the analysis part. Now what is the input? So its input is simple, right? You have been given an integer number that was 153, and the number of input was only one. Then only one digit was given to you. Only one number was given to you, right? This was the number that was given to you. So this is 153, which is an integer, and then the number of input is 1. So what is the output? So output is assumed to be Boolean, either true or false. Again, only one output has to be returned, right? Either a true or a false. So this is the input and the output. Why? So this was the input and this was our output, right? So input output, right? So this was input and this is our output. Great. So now let's get started with the constraints. So what are the conditions? People were asking, right? What are the conditions, right? What are the conditions? What are the constraints? What do you mean by constraint? Constraint means simple conditions. Okay. What are the conditions? That a number must not end with 0. So this 153, if this is a number, then you won't be able to solve it, and it has been given to you that this number will never be such number which ends with 0. Okay, this has been given to you. The condition of an Armstrong number, right? You have to keep that in mind. What is the thing that you have to keep in mind? The condition for Armstrong number, right? What is the condition? That 1 raised power 3 plus 5 raised power 3 plus 3 raised power 3, if you add them up, it comes out to be 153. So this is the thing that you have to also keep in mind. Okay, so number of digits, if it's not given to you, so how you calculate the number of digits, you have to keep that thing in mind. These are the constraints, right? What is the condition for Armstrong number? How you calculate the number of digits if it's not given to you? This 153 is the number. How you calculate that there are only 3 digits? Anyone? Any guesses? Quickly in the chat section. Yes, no, maybe. And the number should not end with 0, right? So quickly, first tell me, let's go one by one from backwards. We will start from this thing. How you calculate the number of digits in a given number? Quickly, guys. In here we have 153 and it contains 3 digits. So how you calculate this 3? Quickly, if it's not given to you, there will be some cases where this 3 is given to you. I mean to say, there will be number of 1533 given to you, and it will be given that there are 4 digits. Now in our case, this is not given to us. So how you will calculate this? Quickly, guys, just quickly write in the chat section, yes, no, anything. And there are also many interesting live sessions going on right now in consideration with IPL and all. So you guys can check them as well once you subscribe to our channel. So those will be beneficial for you. And also there are some projects that you can add up again into your resumes. Divided by 10 says Pratap. Okay, great. Mohsin says using loop. Okay, fair enough. Yeah, Mohammed says, Gautam says this. Okay, great. Any more guesses? By using a function. Okay, while by splitting the numbers. Kinjal says, okay, great, Kinjal. Yeah. So now let's see. Yeah, mod by 10. Absolutely right, Prachi. And count the remainder. Exactly. So now let's see. Now first let's see the basic. I mean to say the step 1 in terms of moving ahead with the problem solving. Okay, so the step 1 is flowchart. So what is this flowchart? Flowchart is nothing but a pictorial representation of steps to be performed. That's it. The steps that you are going to perform is your flowchart. Then you enable visualization of a problem. How you visualize your problem, we will see how visualization is done with the help of graphics. Okay, then shows clear data flow with the help of arrows. So now you might be thinking, what is this visualization? Let's suppose I told you, please make a flow chart or draw a flow chart of what, how to make a tea, making a tea, right? So how would you do it? You will visualize, okay, first I will get up and then I will go into the kitchen, then I will pick up the utensils. So you are visualizing this problem. Okay, you need to visualize. Once you visualize, you will draw it out. Okay, step one, let's suppose you are drawing. I will show you what are the things that you need, what are the things that, what are the actual, I mean to say, the symbols that you are going to use. Okay, so those we need to, how to create multiple models in time series with different target axes in all three. Deepak says something that is not relevant to this class. So Deepak, we have to wait. Okay. So now what we're so we you're going to use specific symbols which will define how to take an input, how to check the conditions, right? All those things. So then you will show with the help of arrows the perfect flow, right? This is the step one. Then we move to the step two. Then we move to step three, right? Can be used also, if someone is not familiar with programming language, this can be used as for a non-technical audience as well, as a naive user. If someone is naive and is a layman, right, he doesn't know anything about programming, this thing is such a thing that this will be understood by that person as well, right? Have a definite start and end point. It will be having a starting point, that means you will start your process, and it will be having a definite end points, right? So now let's see the symbols first. So now there will be one terminal, right, where when we write start and end, okay, this terminal will reflect that when we are going to start and when we are going to end, right? The input and output symbols, right? These are the symbols that we are going to use for our input and output. For processing, right, anything that you are going to do in processing, right, you are processing something for input and output. Let's suppose you will say input num, right? This is the input, right? You will say input num. So this number 153 will be taken here. But anything that you do, right, the processing that you take that takes place, right? Let's suppose you are storing this num into some temporary variable. That processing will take place in here, not in the input section. Okay, so now the decisions, if our number is greater than 0, then go ahead and do something, right? It will always have two cases, right? A yes and a no. If it's true, then what happens? If it's false, then what happens? Okay, so then these are two connectors, right? On page connector and off page connector, and then we have arrow symbols to show the flow, right? So now anyone can anyone tell me what is the difference between this on page connector and off page connector in the chat section? Quickly guys. Flowchart is fully used in Raptor tools. Yes Bindesh. Quickly guys, yes, no, maybe, what is the difference between this on page connector and off page connectors? Quickly guys, yes, no, maybe. I'm waiting for you guys. Quickly, what is an on page connector and what is an off page connector? So an on page connector is nothing if you're connecting in the same page, right? If you're trying to connect, let's suppose you are at this position and you are at the end of this page. Now you want to do some operation and you want to be in the same page, then at that time you will use on page connector. And if you have exhausted this whole page, right, then at that time you will use this connector in the different page, this off page connector, right? That means the next page. Exactly, off means next page. Yes, same. Yeah, you're bang on. Great. So now let's get moving. Yeah, now let's see what will be the flow chart of our modified Armstrong number, right? So first thing that we do, we are going to start. Okay, we started, then we will take the input. What is that? Input is num, right? So if anything that you're taking input, which symbol has to use, symbol you have to use? This symbol. Okay, so let me just make it. Yeah, so this is the symbol, right? So now we will check, sorry, now we will check if this number, that is the condition that we are going to build upon, if this number, right, mod 10 equal to 0, now we'll check the number of digits in it. Okay, so now for that, this is num. Okay, so now we will check if it is not equal to 0, that means yes is true. Then what we will do, we will just count, we'll start our pointer. Okay, that means we are counting. We'll use one count variable here. Let's suppose this count variable is equal to 0. Now we'll increment our this count variable based on the what? Based on this number. So now we have 153, okay, and we are doing it mod 10. So obviously when we do a mod of 153, when we do a mod of 153 with 10, so it will give us 3, right? So now we will have 3. Is this 3 equal to 0? No. So this will go in this section, right? This yes section. Now herein we have our count 0, right? Now if this count is 0, now what we will do, we will move ahead, right? So now what we will do, we will try to save this number as this number is, then we will use this number. So what we are going to use, we are going to use a temporary variable which stores 153, and all the changes that we make, because we are going to reduce this number from once we will remove 3, then this number will be 15, and so we don't want to change this num. So that's why I'm using a variable, a temporary variable temp, to store that number. Okay, so all the changes that I do will be reflected in this temp. Okay, so now what we will do, and some of you might be thinking, sir, where is the no condition? You were saying no. Okay, this is the no condition, and I will connect it with at the end with something. Okay, so don't worry for now. Let's put a dot in here, so it will be a reminder for us. Okay, so now we will connect. So now we will use an off-page connector, on-page connector. So once we have used an on-page connector, so now let's move on. Now we will check, is this temp greater than 0, right? If this temp, is this temp greater than 0, right? Yes, it is. Our temp is right now 3, right? Our what will be our temp? So our temp is 153. Is this greater than 0? Yes, it is. So we'll go in the yes section, right, guys? Are you following along? Now what we will do, we will just increment our count. We'll do a plus. So now what our count will be, it will be 1, and our temp is 153. Now some of you might be thinking, so now what we will do, we will just divide our temp by 10. That's it, right? So we are dividing our temp by 10. Now what will be our temp? So do you see all the processing that is going to happen will be in this square kind of a this rectangle type of a box. Okay, so all the processing is done in this, right? So now what will be our this new temp? It will be something that is 15, right? So now 15 will be there, right? So now we will move ahead, and what we will do, we will just again make a loop kind of a thing, and we will bring it back to where, for checking in here, if this temp is greater than 0 or not. Yes, it is, right? So we again move ahead and increment our pointer to 2, count pointer to 2. Again we divide our temp to 15, and it becomes, this time it will become 1, right? Right? So now again, this temp greater than 1? Yes, it is. So again our count will be 3, and this time around our temp will be 0. So now our temp is not greater than 0. So what we will do, we will move ahead and we will go into the no part. This is the no part, and we will again, what I'm going to use, I'm again initializing my temp to num. Okay, again, now this was 0, now again this is 153. You are following along, guys? Quickly, yes, no, maybe. So now I'm going to use again an on-page connector. Okay, now let's move ahead, and now let's see what we are going to do. So all this thing that we did in here, this part second, and this is, let's suppose this is part 1 and this is part second. Okay, so now all the things that we did, we use this to calculate what? The number of digits, right, guys? Calculating number of digits, that's it, right? Yes, great. So now after that, now what we will do, we will just move along, and now our temp is again equal to 153. Now we don't need this count. We have already found out that there are 3 digits in it. So that's done and dusted. Okay. So now what we will do, we will just check. Now what we will do, we will again need one more variable, that is sum, which will this will be the number that we will what we will do. This sum, let's suppose this is we calculate and it turned out to be 153. Then we will compare this sum if it is equal to what, this num that we have already at the starting. So that is why, that is the reason I'm not changing this num and I'm using a temporary variable to store that. Okay, I'm trying to connect the dots. Okay, so this is the reason that why I didn't change my original number. Okay, because at the end I'm going to compare that num with this sum that we calculated. Okay, now what we will do, I will just initialize my new variable, that is sum, and it is equal to 0. Okay, now we have another variable sum and it is equal to 0 at the starting. Okay, now what we will do, we will check, okay, if this temp is greater than 0. Okay, now if this temp is greater than 0, what will happen? That means there is something in this temp. Okay, so now what we will do, we will store it in a variable. Okay, x, if this is yes, and then we will store it in a variable x, and then what we will do, we will try to take out numbers one by one. So mod divide what I did here. So our temp is 153. Now I did a mod operator. So what will be the number that comes out? It will be 3, right? Modulus gives you a remainder. So it will come out to be 3. So we have 3 in this x. Now what we will do, and what we will do, the next step will be, we will be reducing our temp, that is temp divided by 10, right? This is the next step that we will do. So now our temp will be 15. Okay, this is obvious, right? Now what we will do, we will just initialize our sum with what? We will do sum plus. That means every time that if we find a value, we are going to increment it with our sum. So earlier sum is 0. Right, now what I did, I incremented the new value that will be calculated here. So what I will be doing, I will be using a power function, that is POW, a power x raised power count that we have calculated, right? Count is 3. So x is, now earlier I told you that x is what? X is 3. So 3 raised power 3, it will be 27. This will be added with our sum. So our new sum will be 27, right? And then again we will go back and check if this temp is greater than 0. Yes, it is 15. It is greater than 0. You are following along, guys? Quickly, just give me a yes or a no. Quickly, this is easy stuff, right? Great, Prachi says yes, right? So now it will check again. Now it will be checking. Now our sum was earlier 0 and we did 27. We added 27 to it. Now our sum is what? 27. Now we will be adding what to it? It will be 5, and 5 raised power 3 will be 125. So we'll be adding 125 to our 127, and it will be 152. Next time there will be 1 in it. Okay, so next time it will be added 1 to it. We will be adding 1 to 152. So once we added 1 to 152, it will be sum will be 153, and this will become 0. So now is our temp greater than 0? No. That means we are in the no part, right? That means we are in the no part, right? So this no part, and that at that time we will just do one thing. Let me just erase this thing. I can't find my pointer. Yeah, okay. 1 second, guys. So let me remove this calculation that we did here, and I will try to finish it in the same page. You can click or you try to write this thing on your own when you do this problem. Okay, obviously it will be available on our channel. Okay, so yeah, so now what we will doing, once this no is done, then we will be using again this connector, and we will check again this condition. What we will do, if sum is double equal to what? Num. If it is, then yes, right? Then yes, and we will write a true. We'll print a true, right? And then what we will do, we will end. We will write end. Okay, now what if it doesn't come out to be true? Then again we will write a false statement. A false statement will be here if it is not, and again it will be ended here. Okay, it will be connected with this, and it will also end in here. And this pointer that I showed you earlier, right, that I'm going to use this, if our number is equal to 0, right, that means there is no Armstrong number. So this will be connected with this thing. A false, let's suppose this comes out from this thing, and this is the line that of no, this is the line of this is this line, that dot line that we had, and we will connect it will this false. Okay, and then it will be also ending here. Okay, so it is little bit messy, but you got the point, right guys? Quickly give me a yes or no. And even if you don't understand this thing, it's okay, just go through it, go through the video once and try to figure out each and every step, and how each and every step will make sense once you will go through it. Okay, quickly just give me a yes, no, maybe. Or you can use the connector also here. Okay, you can use that connector and you can add up all those no signs in here. Okay, all these signs, this sign, this above arrow and all those things, and at the end you just use one single line, and then you will just end this here, start and end. Okay, okay, great. Vince says we are following. Great, Vince. So yes, I can see many yeses. Great. So now let's see what is a pseudocode. So pseudocode is nothing but a step-by-step approach of a problem in simple English. You see, English. So if you think that there is any proper, so how can I know the method is well suited in a block of statement in programming language? How can I know a method is well suited in a block of statements in programming language? So, Kashyap, can you just please explain me what you are trying to say? So, you are saying that if that you have a method and you want to know if that method or that block of statements in programming can be converted into flowchart. Is that what you're trying to say? Quickly. Now, the pseudocode. Now, if someone says you, is there any proper structure of a pseudocode, how to write it? There is no structure. As this is simple English language, if you say, I will write my for loop like this, for from I to 0, let's suppose you are writing that I am using a for loop. For loop is used, right? Let's suppose you use this sentence for this for your pseudocode. Is it wrong? No, it is not wrong. It is correct. Okay, don't have to worry. It can be easily understood by a layman. That's the main objective of this pseudocode, that it should be understood by a layman and follow no programming construct. Okay. Prachi, what the pseudocode part or the question or the flowchart part? Right. So now it should not follow any proper what? Okay, one second. So it should not follow any in short. Okay, the previous flowchart, Prachi. So now it can be easily understood by a layman, right? So follow no programming construct. Okay, it basically maps the flowchart in simple statements. Now we will be mapping this flowchart with the pseudocode. Okay, right? One second. With this pseudocode, okay, we'll be mapping this flowchart with this pseudocode. Okay, serves in documentation purpose, which is vital in organization. Okay, this is just an application. Okay, so now what will be the pseudocode? Input a number, right? Now Prachi, this will be help you understand better, right? The pseudocode, right? Input a number, right? We had a number. We check the last digit if it's if the number was what we checked, if the number is equal to, if num mod 10 is equal to 0, then return a false, right? That we did in here, this thing here. We checked this, if the number is, then we did what? No, and we returned it to false, right? This is what I did here. And if it's not, then count the total number of digits in the number, right? We did that. Yeah, Prachi, we will get into that. After this pseudocode, we will have an algorithm wherein we will focus on algorithm part. Okay, don't worry. So we will count the number of digits, then take each digit and add it raised to the power of the number. That's what we did, and add it to the sum variable, right? We had, in the end, we had a sum variable, and herein what we used a count variable, right? So this was the step. This was the step how we mapped, right? And then finally, what we did, we checked if the number that we obtained, that sum, we checked if this sum is equal to the number. If yes, then return a true, else return a false. That's what we did in nutshell. Whatever we did in a flowchart, and all those messy things, messy flowchart, right? All those things, what we did, we just wrote that thing in here. It is a simple pseudocode for that. How simple is that? The pseudocode as compared to this flowchart that we did, right? Okay, now this is a pseudocode. Now, how to convert this pseudocode into an algorithm, right? It is more close to a programming language, right? To the actual programming language that we use. So earlier, let me show you the difference, right? The pseudocode much more related to English, wherein this algorithm is much more relatable to programming language, right? It follows a programming construct to some extent, right? Some programming construct will be followed, which was not the case in pseudocode. There was no programming construct, right? We were not using any programmatic language specific, right? We are using a for loop, check that, check this thing, right? We were not using those things, right? So now algorithm is independent of any programming language. Next step, it should not be language specific, okay? It should be independent from that. Analyzing time complexity, it is used to analyze the space and time complexity, right? And it can be used for further optimization, right? How to make our code more efficient, right? That is what it is used for, algorithm. Okay, so now let's see the algorithm of modified Armstrong number. So you have an input number, then you see if will remain same almost for any programming language, so not related to programming. So can we use while loop instead of for loop? Yes, you can. Yes, you can. So now num mod 10 if is equal to 0, we will return a false, else we were storing temp in num. Then we use a count variable, then we used a while loop, right? Then temp will be greater than 0, then we counted all the digits, we counted here all the digits, right? And then at the end we used, again I initialized my temp as I told you earlier, that we are not going to change this num as we are going to use it in the end, right? That when once we have sum equal to what, this num, right? We were using this num, so that's why I'm using this temporary variable. And again, after some changes that I did to this temp, I am reinitializing it to num. Then I had this sum variable which is equal to 0 for now. Then I incremented, I use this math function, right? You can use any power function or you can calculate it yourself, right? So just for the simplicity, I use this power function. So I calculated the sum. It turned out to be 153, right? And after this loop is this while loop is exhausted, right? I checked if the sum is equal to num. If that is the case, then I return yes, or then I return true, else I return false. So this was it. So this is in nutshell your Armstrong numbers algorithm. Okay, you see now, you see the difference, right? So it is just a little bit related to programming language, and herein we didn't use any programming constructs, right? So now this was it. So now let's see how to implement. I want you guys to implement this in any programming language, so that's why I'm not implementing it. But algorithm and pseudocode is always there. You can refer to that. You just have to change the language specific. You just have to use a scanf. If you're using C, you use scanf for scanning the number. Then you use if statement. Then you calculate its number of digits. It's easy. Everything is written. Everything is present on your screen, right? So Prachi says, at the rate Akshay, while you know how many times we yeah, that is the difference between a while loop and yeah, how to become an expert in any programming language. So basically there is a series of steps that you need to follow. Okay, guys. So the first is pick a language. Pick any language that you're comfortable in. Once you pick the language, now it depends. Are you looking for CP, that's the competitive programming, or you are looking for to code, or you are trying to become a coder, right? The CP will play a major role in that. Now let me show you something that excites you, right? That you might get excited to learn coding a bit more. Okay, so now this is it, right? You need to implement this thing. Now let's see this question. Okay, guys, so I'm not going to go through all the steps. I'm just straight away going to the problem statement and then its implementation. Okay, so these flowchart, pseudocode and algorithm, flowchart, pseudocode and algorithm, you try to figure it out. Okay, so just I'm trying to you see how I will reduce my time complexity, okay, from one algorithm to another. Okay, so now this is the question. Find the first element that is repeated once in the array where every other element is repeated twice. So you see 1 is present twice. You see 1 is here, 1 is here. 3 is present twice, 3 is here, 3 is here. 5 is only once and 6 is present here and here. So all the numbers are present twice except this 5. Okay, so this is the problem statement and you need to return that number. So you have an array and you have to return that number. Okay, this was the problem statement. Okay, so again 10 10 is here, okay, 30 is here, 30 is here, 50 is absolutely alone, and 60 is here. So 50, you have to return this. So this is a problem statement. Okay, now let's see the first approach. So the first approach is quite simple, that you are going to use a nested loops, and wherein our time complexity will be n cross n. So if you don't know anything about time complexity, think of it that in that way. So in this way, right? So you are having this first loop, right? And it is iterated from 0 to arr dot length, right? The language that I'm going to use is Java. If anyone is not aware of Java, it's okay. The main intuition is not that you should know the language. The main intuition is that you should know how to reduce your time complexity. Okay, I'm just going to use for this printing out the statements. That's it. Else, apart from that, everything will remain almost same. Okay, for all the rest of the programming language, right? So now I'm going to iterate from 0 to n, right, guys? In the first thing, right? The n, where n is the length of the array. Let's suppose n is 5. So now in the first loop, that it will iterate for 0, it will iterate n times. For 1, it will iterate again from n for n times. So for n, it will iterate n times. So that is why the time complexity is n square. So how you approach this problem? So you are going, if you have this, what you have this question in here, right? What is the question? 1 3 5 6 6. So we have 1 3 5 6 6 1, right? Let's suppose 3 1. Okay, then we have 5. Okay, so now first, what you are going to do, the outer loop 1, this one element will be compared with each and every other element, right? It will check, right? And also we are checking that it should not be on the same index, else we will get our answer, right? Yeah, Prachi, yeah, that is absolutely right. Yes, Prachi. So now what we did, we compared it each one by one, we compared it with every other element. If it finds a pair, then it's okay, then we will move ahead. And if it's not, except this element, because this is the element that we choose. So that's why we are doing here I not equal to j. That means the indexes are not same, right? Absolutely, Shashank, dictionary in Python, yes. We will use hash tables in here because I'm using Java, right? So that can be also. So now the focus is that here. So once we will be able to find this in, let's suppose 1 is compared, then 2 is compared, then 3 is compared. So that is why the time complexity of this is n square. So now if we were not able to find any such pair, then we will return that there are no such pairs. And if else we have a flag equal to 0, so at that time we will print it. So go through this. This is nothing but we are using 2 for loops, and so that's why the time complexity is n square. So now this is the first naive approach that one can think of. But if you give this approach in your coding interview, you will never be selected. Okay. So now let's move on to the next step. The next step that comes into your mind. So now, okay, this is the thing. Now you thought of, okay, let me just sort this array. So let's suppose we had this array 1 3 5 6 6 3 1. Now if we sort this array, it will be 1 1 3 3 5 and 6 6. So now what we did, we checked if this I and the next element is equal, right? Are they equal? If they are equal, that means we have a pair. Now if they are not equal, that means we don't have a pair, which will be case in this 5 and 6. They are not equal, so we will print out that statement. Okay, simple enough, right? Now, but the time complexity, even though you're using a single loop, it will be n for this, that you're using only single loop. But for sorting this, it will be n log n, right? Again, the time complexity, you reduced it from n square to n log n. But can it be reduced any further? The question is that. Yes, it can be. So this time, as Shashank rightly said, we are going to use a dictionary. But in here, we are using Java as our language. So we are going to use a hash map, wherein we will store the number and its frequency. So the first number will be, let's suppose 1, and we will store its frequency. So the 1 is twice, then we have 3 is twice, and then we have 5 was once, and 6 was twice. Okay, so this was the hash map that we created, right? So if anyone is not aware of this, no need to worry. I'm just showing you how to reduce your time complexity. Okay, so now we will check. We will first create this map with the help of these statements. Okay, with these statements, this map will be created, which will be something like this. Okay, you don't have to worry about this. Okay, then we will check if the number that the frequency that we stored, if for any of these elements it is 1, that means that number is not repeated. Okay, we will check that thing in here in a single loop. So the time complexity of this is order of n. For this, it is also order of n. So this is order of, this will be n plus n. So that is why the time complexity is n. But we are using some extra space, that is big O of n. So that is why what we had done a trade-off between time and space. So earlier it was n log n, but space was constant. But right now in this case, what we did, we have a time complexity that is obviously reduced from n log n to n. Earlier it was n square, but for both these cases space complexity was constant, but in this case the space complexity has increased to order of n. Okay, makes sense, right? So we have done a trade-off, but it will be obvious to interviewer that you will be doing something like this. Okay, so you don't have to worry. Okay, so now after that, now can you reduce it any further? Can you somehow skip this space complexity? Yes, you can, using an XOR operation. So in this case, the time complexity will be order of n, but the space will be constant. So this is the most efficient approach, and if you solve this in your interview, there is no way that you will be rejected. Okay, you will be always, there's a chance that you will be selected based on obviously if you will ask you something else that you don't know, then obviously your chance will reduce. Okay, but for now it will be obvious for him that you know this, you know something about coding. Okay, so now herein what we are going to use the concept, right? So how XOR works in such a manner that, let me show you this slide first. So if you have the same output, that it will give you 0, and if you have something that is different, it will always give you 1. Okay, so now we will take this step into consideration, that if there is something same, that means we will be getting a 0. So now we will be doing the same stuff again. Yes, I will explain this XOR. So now we will be doing the same stuff here. So here if we have 1 3, then we had 5, okay, then we had 6 6, then we had 3 1. So now what we knew of this XOR, that if output is same, if both the input bits are same, that it will always result in 0. So that's what we are going to use. So what will be the binary of this? It will be lots of zeros then 1, same, lots of zeros and 1. So both of these binary form of both ones will be same, and will it result in 0? Yes or no? Yes, right, it will result in 0. So same goes for this. What will be the binary of 6? It will be something 110, right? And same goes for the other. So when you do XOR of this, it will again give you a 0. So this will also result in 0. This will also result in 0. So 3 3, again it will result in 0. So all the numbers will be 0 except this 5. As this 5 will be XORed with 0, you will always get a 5. Is there any confusion? Is this clear, guys? Quickly, yes, no, Kinjal. Kinjal says, can you explain XOR? Is it clear, Kinjal, now? So why this is, how this came out to be this thing? Now, some of you might be thinking, sir, we are not sorting it. How can it be, how can we use this thing? So this XOR operation means, XOR means that if same inputs are used, otherwise, yes, Prachi, obviously, yes. So now what happens, if you observe carefully, that I did something that is, this XOR operation is commutative and associative. So that means if I do 1 XOR 5, or I do 5 XOR 1, it will be still the same result. It will, okay, so voice is echoing. Is it clear now, guys? Quickly. Be clear, guys. Just give me a confirmation quickly. Yes, no, maybe. Ronak, is it clear now? Ronak, Vince, Kinjal. Now it's clear. Great. So now what I was saying, that some of you might be thinking, sir, okay, this number is something 1 5, then there is 3, you are doing something like this, right? You were doing something like this. This doesn't make any sense, right? So how can this become a 3? How will we get this value as 5? So what I told you earlier, this XOR operation is commutative and associative. So I can pick this number and put it here, still it won't be affected, right? If I do this thing, right, 1 cross 1, I pick this 1 from here to here, right? It won't make any difference in the result, okay? Because this is commutative and associative. I can make these changes, right? So now what I have after that, I will do 6 this stuff. I will just change this to this, and then finally I can put this 5 anywhere, that it won't be affected in my result, it won't affect my result. So now no sir, it is not clear. Okay, MDS. So now what I was saying, that this is commutative and associative. So now what will be the result of this? It will be 0, right? 6 6, it will be 0. 3 3, it will be 0. This 5, it will be again 0. So now 0 XOR 5, it will be give me 5. So that is the number that was repeated. Sir, how to become expert in problem solving? Practice, practice, practice. A lot of practice is required, Keshav. Okay, so now this is the thing. This is how we reduced our time complexity and space complexity from, you see, now what was our path? So the path was something like this. Let me show you how was your path. So path was that we started from n square, right? We reduced it to n log n with the help of sorting. Here we use two loops, here we use sorting, and then we reduced it further. We reduced it to n with the help of hash maps, right? Or dictionaries, anyone, right? So now, but we increased our space complexity. Our space complexity was order of n here, and in here it was constant. In here it was constant. Then finally, how we reduced it further to n, but we reduced our space complexity to constant with the help of XOR operation. Okay, so this was our path, right, of solving this problem. So XOR basically means two objects are similar, then the result will be true. Either it will be false, not false, it will be something else. Let's suppose you have a binary number, you have 4 and 6. If you do a XOR of this, let's first convert this 4 into binary. What will be this? This will be the 4, 1 2 and 4. This is how you convert into binary, 1 0 0, and for 6 it will be 1 1 0, right? So now if you do an XOR operation, so these two bits are same, it will result in 0. These two bits are different, it will return in 1. These two bits are same, it will result in 0. So it is not either true or false, it is something that is dependent on this, the bits. Okay, so now what will be the result? It will be 2. Okay, is it clear? Okay, there is something, Raghavendra, there is something that is called STL. If you have something, I am not sure of, but there is something. Okay guys, so this is it from this session. I hope you enjoyed this session. Okay, so see you in the next session. Let's do, maybe if we okay, Kinjal says it's clear. Great. So now this is it from this session, guys. I hope you enjoyed it. Now what is your task? Please go ahead and solve that modified algorithm, modified I'm saying algorithm, that modified what was that, modified Armstrong number. Please go ahead and try to implement it any programming language that you guys are comfortable in, and let's see you in the next session. Okay guys, so thanks a lot guys. Thank you guys. Is it a series? Not sure of, Raghavendra. Not yet, sir, I have a doubt. Yes Prachi, go ahead. Any questions? That, sir, I have a question. Go ahead guys, go ahead quickly, we are running out of time. Is list and array same? No Prachi, if you're talking about array list and arrays, so the main difference there is, although they work in a similar fashion, but the main difference is that in arrays you have to specifically specify that this is the size of this array, but in list you can add and delete at any point of time. Okay, yeah, I believe they both are similar mutable structures. No Kinjal, they are different. Okay, Rohan, go ahead with your question quickly. Any more questions guys? So if there are no questions, I'm going to sign off. All right, so okay, understood. Great. So thanks a lot guys, see you in the next, and stay safe, and do also subscribe our channel, and yeah, that's it. See you in the next session guys. Thanks a lot, and thank you so much. Thanks.